Right now, as you read these words, the nearest star to our sun is sitting at a distance so vast that the number itself becomes meaningless the moment you hear it. 25 trillion miles. A 25 followed by 12 zeros. Your mind registers the figure, the way it registers the national debt or the age of the universe, as an abstraction, a symbol on a page that carries no real weight, no texture, no emotional truth. So let us try a different way. If you drove a car at highway speed, 65 miles per hour, without stopping, without sleeping, without ever pulling over, it would take you approximately 43 million years to reach Proxima Centauri. The dinosaurs went extinct 66 million years ago. You would not even be halfway there. But here is what most people get wrong when they first encounter that number. They assume the problem is simply speed, that if we could just go faster, 10 times faster, 100 times faster, the universe would open up to us. That the stars are waiting, patient and accessible, needing only a more powerful engine to bring them within reach. The real situation is far more devastating than that. Even at 1% of the speed of light, a velocity so extreme that no human being has ever come remotely close to experiencing it, a velocity that would carry you from New York to Los Angeles in less than 2 seconds, the journey to Proxima Centauri would take over 400 years, 4 centuries, longer than the United States has existed as a nation, longer than the entire Baroque, classical and romantic periods of music combined, and Proxima Centauri is the closest star. The interesting ones, the systems with planets that might harbor liquid water and breathable atmospheres, are farther, much farther. We are talking about journeys of 500 years, 1,000 years, 2,000 years. No human being lives that long. This is the wall that stands between humanity and the stars, not politics, not funding, not the will to explore, physics itself. The universe is structured in such a way that the distances between stars are almost perfectly calibrated to be just beyond the reach of any single human life, no matter how long or how fast. It is as if the cosmos drew a line and said, "You may look, but you may not touch. You may dream, but you may not arrive." And yet, there is one theoretical solution that does not require faster than light travel, does not require physics we have not yet discovered, does not require technology that exists only in equations on a whiteboard. It requires something far more disturbing. It requires people, generations of them, entire lifetimes, stacked one upon another like geological strata, compressed into the hull of a ship, crossing the dark between the stars. You send not a crew, but a civilization, a small, sealed, self-sufficient world traveling at a fraction of light speed through interstellar space for centuries. The people who board the ship will never arrive. Their children will not arrive. Perhaps their grandchildren will not arrive. The destination belongs to descendants not yet born, to faces no one on board will ever see, to a world that exists for most of the journey only as a point of light in a telescope. This is what we call a generation ship. And if you are comfortable right now, if you are warm, if the air around you is clean and still, if you can look out a window and see sky, then you should understand that everything about your relationship to those simple facts would be different if you had been born on one. If you find yourself drawn to questions the universe does not make easy to answer, do me a small favor and hit that like button and subscribe to this channel. It genuinely helps this work reach more people who want to think carefully about where we are and where we might be going. Now make yourself comfortable. We are going to be here for a while. Let's begin. The concept of a generation ship is not new. Science fiction writers imagined them long before rocket engineers took them seriously. But in the last several decades, the idea has migrated out of novels and into academic papers, engineering proposals, and quiet conversations among the people who spend their careers thinking about humanity's long-term survival. Organizations like the British Interplanetary Society, researchers at institutions like NASA's Jet Propulsion Laboratory, and independent scientists publishing in journals like Acta Astronautica have all engaged with the question in technical detail. The conclusion they keep arriving at is uncomfortable. Generation ships may be the only realistic path to the stars, given physics as we currently understand it. To understand why, you need to first understand the energy problem. Accelerating a spacecraft to any meaningful fraction of the speed of light requires energy on a scale that is genuinely difficult to communicate. Consider this. Accelerating a single kilogram of mass to just 1% of light speed requires approximately 450 billion joules of energy. That is roughly the energy released by 100 tons of TNT for a single kilogram. Now consider that a generation ship, a vessel large enough to carry a viable human population with all the agricultural systems, manufacturing equipment, medical facilities, water recycling infrastructure, and living space that entails would need to have a mass of at least several million kilograms, probably much more. The energy required to accelerate such a structure to 1% of light speed would exceed the total energy consumption of every human being on Earth over an entire year. We do not currently have a propulsion system capable of delivering that energy efficiently. Nuclear pulse propulsion, a concept developed in the 1950s under Project Orion, proposed detonating nuclear bombs behind the spacecraft and riding the resulting shockwave. The physics works, the engineering is brutal. The political and environmental implications of launching a nuclear bomb-propelled spacecraft from Earth's surface are significant enough that the project was quietly shelved. Fusion rockets, which would harness the same process that powers stars, remain theoretically attractive, but practically elusive. We have been working on controlled nuclear fusion for over 70 years, and we are still not generating more energy from fusion than we put in to sustain the reaction, though that threshold was crossed for the first time in late 2022 by the National Ignition Facility in California, a milestone that was celebrated precisely because it had taken so long to reach. Antimatter drives, which offer the highest possible energy density of any known fuel, require manufacturing antimatter in quantities we cannot currently produce. The entire global output of antimatter from particle accelerators amounts to a few nanograms per year, enough to power a light bulb for a few minutes. So we are left with speeds that are achievable, speeds in the range of 1 to 5% of light speed that might be reached within the next century or two, given sufficient technological development. And at those speeds, the journey to the nearest interesting star systems takes somewhere between 1 and 2,000 years. 1,000 years. Think carefully about what that number means in human terms. 1,000 years ago, William the Conqueror had not yet invaded England. The Catholic Church was approaching the apex of its temporal power in Europe. The Aztec civilization did not yet exist. The great cathedrals of Europe were either just beginning construction or had not yet been conceived. The English language spoken today would be completely unrecognizable to anyone alive in 1025. Not just difficult to understand, unrecognizable. The words, the grammar, the sounds, all of it transformed beyond recognition by 1,000 years of drift and change. This is the timescale of a generation ship voyage. You are not sending a crew. You are sending a culture, a living, breathing, evolving human society sealed inside a metal shell and pointed at a star, and that society will change. It will grow and mourn and argue and love and fracture and reform and change again and again and again for 1,000 years. And at the end of that process, the people who step off the ship and onto the soil of a new world will not be the people who boarded it. They will be their descendants, shaped by a millennium of life in a closed system, carrying the memories and values and traumas of 30 or 40 generations of ancestors who lived and passed in the dark between the stars. To begin to understand what that life would actually be like, you need to first understand the physical reality of the ship itself, not as an abstraction, but as a place, a specific, bounded, inescapable place that would constitute the entire known world for every person born on board after departure. The ship would need to be large, not large by the standards of current spacecraft, which are remarkably compact given the complexity of what they do, but large in an architectural sense. Large the way a city is large, because a generation ship is not a vehicle in any conventional sense. It is a habitat, a farm, a hospital, a school, a factory, a cemetery, and a home, all contained within a single structure that must function flawlessly for centuries in an environment that offers no mercy and no assistance. The minimum viable population for a generation ship has been studied carefully by geneticists and population biologists. The number that appears most frequently in the serious literature is somewhere between 1,000 and 10,000 individuals. The lower figure, around 1,000, is considered by some researchers to be dangerously small, a population that could maintain genetic diversity under ideal conditions, but would be catastrophically vulnerable to any significant reduction. John Moore at the University of Florida published analysis suggesting that a minimum of 160 individuals with careful reproductive management could theoretically maintain genetic viability over a long journey, but most researchers consider that figure optimistically low. A more conservative and widely cited figure comes from a 2014 study by Cameron Smith at Portland State University, which concluded that a ship population of around 10,000 to 40,000 individuals would provide adequate genetic redundancy and resilience against unexpected population loss. 10,000 people. That is a small town. A small town that needs to grow its own food, generate its own power, manufacture its own replacement parts, treat its own medical emergencies, educate its own children, and resolve its own conflicts, all without any possibility of outside assistance for 1,000 years. The living space required for 10,000 people, even at the relatively compressed densities of a modern urban apartment building, would amount to hundreds of thousands of square meters. Add to that the agricultural space required to feed those people hydroponic systems, closed-loop water and nutrient cycling, artificial lighting to replace sunlight, and the engineering scope becomes staggering. Add the manufacturing facilities needed to produce replacement components. Add the medical infrastructure. Add the schools, the communal spaces, the recreational areas. Because human beings who live without space to gather and breathe and move gradually break in ways that are no less real for being psychological. The most commonly proposed architectural solution is the O'Neill cylinder, a concept developed by physicist Gerard O'Neill in the 1970s. An O'Neill cylinder is essentially a hollow tube, several miles long and roughly a mile in diameter, that spins along its central axis. The rotation creates centrifugal force along the inner surface of the cylinder wall, which mimics the effect of gravity. People living on the interior surface of the cylinder would feel pulled toward the wall, which becomes, from their perspective, the floor. The sky above them, looking inward toward the axis of rotation, would curve upward and away in both directions, meeting at the opposite side of the cylinder. Stand in the middle of such a habitat and look up, and you would see the rest of the world arching overhead. Other fields, other buildings, other people, all visible hanging above you like a landscape reflected in the inside of a bowl. The horizon does not recede, it curves upward. The sky is not sky, it is more floor. This is the world into which children would be born on a generation ship. This curvature, this ceiling that is also ground, this total enclosure that no journey, however long, would ever escape. And yet, for the people born into it, it would simply be the world, the only world. The way the curve of the earth beneath your feet is simply the world to you, not a constraint, not an engineering compromise, just the shape of existence. Children are extraordinarily adaptable in this way. They build their understanding of normal from whatever they find around them. The child born on a generation ship would find closed corridors normal, would find recycled air normal, would find a sky that curves overhead and meets itself on the other side normal, would find the faint hum of life support systems, the constant, omnipresent sound of the machinery that keeps everyone alive as unremarkable as the sound of wind. But knowing that a thing becomes normal does not mean it is without cost. There is a branch of environmental psychology concerned with how physical spaces shape mental states, and the findings accumulated over decades of research point consistently in one direction. Human beings need variety. We need novelty. We need spaces that change, that offer different experiences at different times, that do not resolve themselves into a perfectly predictable sameness. We need to be surprised by our environment, occasionally. The ability to walk in a direction and not know exactly what you will find is not a luxury. For our species, which evolved roaming across varied landscapes, seeking new food sources, exploring unfamiliar terrain, It is something closer to a biological requirement. A generation ship cannot provide this. You can walk every corridor of the ship. You can map it completely in your mind. You can know with perfect certainty every room, every surface, every view, because the ship does not change. The corridors are where they were yesterday and where they will be tomorrow. The hydroponic bays smell the same in year 30 as they did in year 1. The observation deck offers the same view. Stars, motionless against the black, changing only imperceptibly slowly over years as the ship moves between them. The destination star grows brighter by a fraction each decade. Everything else is fixed. This fixedness is not trivial. Studies conducted on research teams overwintering in Antarctica, one of the closest terrestrial analogues to the psychological conditions of a long space voyage, consistently show that after several months of isolation in a confined environment, crew members experience elevated rates of depression, cognitive decline, interpersonal conflict, and a phenomenon researchers call the third quarter effect, in which morale drops most sharply during the period when the crew knows the end is not yet in sight. But the novelty of the experience has long since worn off. On an Antarctic expedition, the third quarter effect lasts weeks, perhaps a few months. On a generation ship, it lasts lifetimes. The first generation boards the ship with the memory of Earth fresh in their minds. They have walked under open sky, they have felt wind, they have seen horizons that extend to the curve of the planet. They carry all of that with them, and in their early years on board, the contrast between what they left and where they are now is vivid and painful. But that pain is at least oriented. They know what they are missing, they can name it. They have a before. Their children have no before. Their children are born into the ship. The ship is not a departure from something else. It is simply everything, the entire category of existence. And that means the loss that the first generation felt, the grief for open sky, for unrecycled air, for ground that does not end, cannot be felt by the second generation in the same way, because you cannot grieve something you have never known, but it can be felt in a different way, as a kind of hunger without a name, a reaching towards something undefined and unavailable, a sense that the world is smaller than it should be, without knowing what larger would feel like. This is where the generation ship begins to reveal its deepest challenge. Not in the engineering, not in the propulsion, in the human beings who must live inside it, generation after generation, carrying a mission they did not choose, toward a destination they will never see, for reasons that become more abstract and more distant with every year that passes. Right now, the ship is still in the early decades of its journey. The founding generation is still alive or recently gone. Their children are young adults, shaped by stories from people who remember Earth firsthand. The mission feels real, feels connected to something, feels like it has a source and a meaning that can be traced back to living memory. But now imagine you are 200 years in. The last person who was born on Earth passed 80 years ago. The last living connection to the world that launched this ship is gone. What remains is record. Recording, text, images, the accumulated documentation of a civilization that sent this vessel into the dark. But documentation is not memory. It is not the weight of personal testimony. It is history. And history, however carefully preserved, does not carry the same authority as the living voice of someone who was there. The people alive 200 years into the journey have grandparents who had grandparents who had grandparents who boarded the ship. Earth is not a place to them. It is a story, a very old story. And stories, over time, do what stories always do. They simplify, they mythologize, they accumulate, meaning that has less and less to do with the original facts and more to do with the emotional needs of the people telling them. The mission by this point is no longer something chosen. It is something inherited, something as given, as immovable as the metal walls of the ship itself. You did not decide to be on this vessel. You were born here, you will pass here. The destination belongs to people who do not yet exist. The origin belongs to people who no longer do. You live in the middle, in the long present tense of a journey that has no edges within your experience. Would you go? Would you board a ship, knowing that you would live your entire life inside it, that your children would live their entire lives inside it? that the world you are traveling toward is a point of light in a telescope, unreachable within your lifetime or your children's lifetime or your children's children's lifetime, the question feels almost impossible. And yet it is the question at the center of everything we are about to explore. Because somewhere between the physics of interstellar travel and the philosophy of what we owe to future generations, there is a decision, a specific, irreversible, consequential decision about what humanity is willing to ask of itself in order to reach the stars. And everything that follows from that decision, every birth on board, every passing, every conflict, every moment of meaning found or lost in the dark, flows from whether we understand, truly understand, what we are asking. We are not asking people to take a long voyage. We are asking people to give their lives to a voyage that will never end for them. The ship moves through the dark. The stars do not move. The destination grows imperceptibly brighter, year by year, decade by decade, the way a candle far down a corridor gets only slightly less distant with each slow step toward it. And the people inside the ship live. They work, they love, they argue, they mourn, they teach their children, they grow old, they pass and are replaced by the children they taught, who will do the same, who will also pass and be replaced, on and on, through the dark, through the silence, through the centuries. This is the generation ship, and we are only beginning. The first thing you need to understand about building a generation ship is that you are not building a spacecraft. You are building a world. The distinction matters more than it might initially seem. A spacecraft is designed to get from one place to another. Its job is transit. It carries its passengers through an environment hostile to life and delivers them to their destination. And once it has done that, its purpose is fulfilled. Everything about its design is oriented toward that single function. Efficiency, speed, the ruthless prioritization of what is necessary over what is merely desirable. A world is different. A world has to sustain life not for a journey measured in days or months, but for existence measured in generations. It cannot simply transport its inhabitants. It must feed them, shelter them, provide them with clean water and breathable air, give them places to work and rest and grieve and celebrate. It must do all of this without resupply, without maintenance support from outside, without the ability to call for help when something goes wrong. And it must do it not once, not for a single carefully planned mission duration, but continuously, indefinitely, for as long as the voyage lasts. No human being has ever built anything like this. The International Space Station is the most complex and expensive structure humanity has ever placed in orbit. It has been continuously inhabited for over 20 years. It is a marvel of engineering and international cooperation, and it is completely dependent on Earth. Resupply missions arrive every few months carrying food, water, spare parts, scientific equipment, replacement crew. Without those missions, the station becomes uninhabitable within weeks. The life support systems that keep astronauts alive on the ISS are not self-sustaining. They are extensions of Earth's industrial infrastructure, connected by a supply chain that crosses 400 kilometers of near vacuum. A generation ship would need to sever that supply chain entirely. Everything the ship needs for a 1,000-year voyage must either be brought on board at departure or produced on board during the journey. There are no exceptions, no emergency resupply options, no possibility of a quick turnaround back to Earth if something critical is forgotten or depleted. The ship is, from the moment it leaves the solar system, on its own. Begin with the most fundamental requirement of all, air. The atmosphere inside the ship must maintain a composition close enough to Earth's surface air to sustain human life. Roughly 21% oxygen, 78% nitrogen, trace amounts of carbon dioxide, and other gases. Every breath taken by every person on board consumes oxygen and exhales carbon dioxide. Over a single day, 10,000 people exhale enough carbon dioxide to pose a serious threat to the air supply if it is not continuously removed and the oxygen continuously replenished. On Earth, this problem is solved by photosynthesis. Plants absorb carbon dioxide and release oxygen in a cycle that has kept the atmosphere breathable for hundreds of millions of years. The generation ship must replicate this cycle artificially. inside a sealed container at sufficient scale to service an entire small city. The primary mechanism would be the ship's agricultural system. Hydroponic bays, vast arrays of plants growing in nutrient-rich water solutions under artificial lighting, without soil, in stacked racks, designed to maximize growing area per cubic meter of ship volume, would serve the dual purpose of producing food and scrubbing carbon dioxide from the air. The math is demanding. A single person requires roughly 100 square meters of crop area to produce both enough food and enough oxygen for survival, if the crops are carefully selected and the system runs at high efficiency. For 10,000 people, that is 1 million square meters of growing area, 100 hectares, sealed inside a ship. That is roughly the size of 1,000 Olympic swimming pools, stacked and packed into a hull that must also contain living quarters, corridors, mechanical systems, water storage, manufacturing facilities, and everything else the community needs. The engineering problem of fitting this volume into a structure that can actually be accelerated to a meaningful fraction of the speed of light is severe. Mass is the enemy of interstellar travel. Every kilogram you add to the ship requires more fuel to accelerate. More fuel adds more mass. More mass requires more fuel. This relationship, known to rocket engineers as the tyranny of the rocket equation, does not become more forgiving at interstellar scales. It becomes catastrophic. The fuel mass required to accelerate a given payload grows exponentially with the desired final velocity. At 1% of light speed, the fuel required to launch a generation ship of even modest size would exceed the mass of the ship itself by a factor of several hundred, depending on the propulsion system used. Every ton of hydroponic soil, every liter of stored water, every spool of wire and sheet of metal and medical instrument, and educational text and musical instrument is a ton, a liter, a spool, a sheet, an instrument, a text that must be fueled across the void. Nothing is free. Everything has a cost measured not in money, but in mass. Water is the second fundamental requirement, and in some ways, the more frightening one. The human body is roughly 60% water by mass. A person needs approximately 2 to 3 liters of drinking water per day simply to survive, and significantly more when physical labor, elevated temperature, or illness is factored in. 10,000 people require between 20 and 30,000 liters of drinking water every single day. Over a 1,000-year voyage, that is somewhere between 7 and 11 billion liters of water required for drinking alone before agricultural use, hygiene, and industrial processes are considered. The ship cannot carry that much water. The solution, in principle, is total recycling. Every drop of water that enters the ship's biological cycle must be captured and returned to the cycle. Urine is filtered and purified. Perspiration is captured from the air through dehumidification systems. Agricultural water is cycled back through root systems. Water vapor exhaled in every breath is recovered. Nothing is lost. In practice, no recycling system achieves 100% efficiency. There are always losses. Small amounts of water become chemically bound in compounds. Small amounts escape the recovery system. In a closed loop running continuously for 1,000 years, even a loss rate of 0.1% per year compounds into a significant depletion. After 500 years, a system with a 99.9% efficiency rate would have lost roughly 40% of its initial water supply. This means the ship must either begin with a water surplus large enough to absorb centuries of losses, or it must find ways to supplement its water supply during the voyage. One proposed solution is to harvest water from interstellar sources, comets, ice-bearing asteroids, or hydrogen-rich gas clouds if any are encountered along the route. But interstellar space is not a reliable hardware store. You cannot count on finding exactly what you need when you need it. The ship must be designed to survive without any external input, and any supplementation must be treated as a bonus rather than a necessity. The same calculus applies to every resource the ship depends upon. Nitrogen, essential for the atmospheric balance and for plant growth, must be kept in the cycle. Phosphorus, critical for agriculture and biological processes, cannot be synthesized from nothing. Every atom that was on board at departure must still be on board centuries later, transformed and recycled, but not lost. The ship is a closed chemical system, and closed chemical systems tend toward entropy. Keeping them ordered and functional requires continuous energy input and continuous vigilance. Power is the third pillar of ship survival, and in many ways the most technically demanding. A generation ship requires enormous amounts of continuous power, life support systems, atmospheric processing, water recycling, agricultural lighting, heating and cooling, navigation, communications, medical equipment, manufacturing systems, and the propulsion system itself. All of these require electricity generated reliably, without interruption, for 1,000 years. Solar panels, the workhorse of current spacecraft power systems, become useless once the ship is more than a few astronomical units from any star. In interstellar space, the light from even the brightest nearby stars is too faint to generate meaningful power. The ship must carry its own power source. The most credible candidate for a generation ship power system is nuclear fission, the same process used in nuclear power plants on Earth today. Fission reactors can run for decades on a single fuel load, produce enormous amounts of power relative to their mass, and a well-understood technology. A well-designed fission reactor could plausibly operate for 50 to 100 years before requiring significant maintenance or refueling. But a 1,000-year voyage requires 10 to 20 complete reactor lifetimes. You cannot carry enough fission fuel for 10 successive reactor loads without overwhelming the ship's mass budget. You cannot refuel in interstellar space. You need a reactor, or more likely an array of reactors, that either runs continuously for 1,000 years or can be rebuilt from materials available on board. Nuclear fusion offers a more attractive long-term solution. Fusion reactors, if we ever perfect them, can run on hydrogen, the most abundant element in the universe. A ship could theoretically scoop interstellar hydrogen as it travels, using a concept proposed by physicist Robert Bussard in 1960 called the Bussard ramjet to continuously replenish its fusion fuel supply. The physics of this approach turns out to be more complicated than Bussard initially envisioned. The drag, created by scooping interstellar hydrogen, may exceed the thrust generated by the fusion reaction, but the fundamental concept of harvesting fuel from the medium through which you are traveling remains appealing. Research into variations of this idea continues. What is not in question is the consequence of power failure. If the ship's reactors go dark, everything stops. Life support stops. Agricultural lighting stops. Water recycling stops. Heating stops. In the cold of interstellar space, the internal temperature of the ship would drop to lethal levels within hours. Every person on board would be gone within days. A 1,000-year mission, carrying the genetic and cultural heritage of a civilization, extinguished by a failure in a power coupling somewhere deep in the engineering section. This is why redundancy is not optional. You do not build a generation ship with one reactor. You build it with 3 or 5 or 10, each capable of sustaining the ship independently, each backed up by emergency systems capable of buying enough time for repairs. You build in redundancy at every level. Multiple atmospheric processors, multiple water recycling units, multiple agricultural lighting systems, multiple navigation computers. Every critical system is duplicated, triplicated, quadruplicated, and every redundant system adds mass. This is the central contradiction of generation ship engineering, the problem that does not resolve itself no matter how cleverly you approach it. Safety requires redundancy. Redundancy requires mass. Mass requires fuel. Fuel requires more mass. And every kilogram you add to the ship in the name of safety makes the ship harder to launch, harder to accelerate, harder to decelerate, and more expensive to build. At some point, you are forced to make decisions about how much redundancy is enough, which systems are critical enough to warrant full backup, and which are not, where the acceptable risk threshold lies. Those decisions are engineering decisions, but they are also moral decisions, because the people making them will be long gone by the time the consequences of their choices become clear. Now consider radiation. Earth's surface is protected from the most damaging forms of cosmic radiation by two things: the planet's magnetic field, which deflects charged particles, and the atmosphere, which absorbs them. Strip those two protections away, and the radiation environment becomes significantly more hostile. Cosmic rays, high-energy particles originating from supernovae, active galactic nuclei, and other extreme astrophysical events stream through interstellar space continuously. They pass through solid matter. They cannot be stopped by a simple metal wall. They can be absorbed by sufficiently thick shielding. But sufficiently thick shielding is very heavy, and mass, as we have already established, is the enemy. The practical shielding solution most commonly proposed for generation ships is water. Water is relatively effective at absorbing radiation per unit of mass compared to metals, and the ship already needs large quantities of water for other purposes. By surrounding the inhabited sections of the ship with tanks of water, perhaps 2 to 3 meters thick, on the most exposed surfaces, you can significantly reduce cosmic ray exposure without adding mass that serves no other function. The water shielding doubles as the water reserve. But even with water shielding, some radiation gets through. The shielding attenuates but does not eliminate exposure. Over a lifetime, the cumulative dose received by a person living on a generation ship would be higher than what a person on Earth's surface receives. Probably not immediately lethal, but not negligible either. Higher cancer rates, possible neurological effects, increased mutation rates across the population over generations as radiation-induced DNA damage accumulates in the germline. And then there are solar energetic particle events, massive eruptions from stars that can deliver intense bursts of radiation in hours. In interstellar space, far from any star, these events are not a concern. But during the initial phases of departure, when the ship is still within or near the solar system, and during the final approach to the destination star, the crew must be prepared to take shelter in the most heavily shielded sections of the ship and wait out the storm. The ship must be designed with these shelter zones from the beginning, deeply shielded rooms where the entire population can huddle for hours or days while a radiation event passes overhead. Rooms stocked with food and water and medical supplies. Rooms that are, in every meaningful sense, a ship within the ship. Beyond radiation, the ship must survive the physical hazards of interstellar travel. And interstellar space, while almost unimaginably empty compared to the interior of a solar system, is not completely empty. The interstellar medium contains dust-tiny particles of carbon, silicate, and ice, scattered through the void at densities so low that you could travel through it for years without noticing any individual particle. But at high velocities, even tiny particles become dangerous. A grain of dust, 1/10 of a millimeter across, traveling at an effective relative velocity of 1% of light speed, carries the kinetic energy of a bullet. It will punch through an unshielded metal hull. At the leading edge of a ship traveling at interstellar velocities, the accumulated impact of dust grains is like standing in a very slow sandstorm, each individual impact negligible, but the cumulative effect over years and decades, adding up to measurable erosion of exposed surfaces. The bow shield, a dense, sacrificial layer of material at the front of the ship, designed to absorb impacts and ablate slowly rather than catastrophically, is one of the oldest concepts in generation ship design. The material choices are constrained. The shield must be dense enough to stop incoming particles, durable enough to survive thousands of years of erosion, and replaceable enough that as it wears away, it can be replenished from onboard materials. Some proposals suggest a thin layer of hydrogen ice, which is cheap by mass and effective at absorbing impacts, regenerated continuously from the ship's fuel supply. Others propose layered composite materials, harder and more durable. What no proposal has fully solved is the problem of large objects. The interstellar medium contains not just dust, but occasionally larger debris fragments ejected from planetary systems, rogue bodies moving through the dark. Most of these objects emit no light of their own. They are invisible against the black until they are very close. At the velocities involved in interstellar travel, the warning time before impact could be measured in minutes or seconds, barely enough to trigger automated evasion systems, certainly not enough for human reaction. A collision with a body even a centimeter across at these speeds would be catastrophic. A body the size of a tennis ball would punch through any shield we could reasonably build and destroy the ship. The probability of any given generation ship encountering such an object during its voyage is low, but low is not zero, and over 1,000 years of travel across dozens of light years of space, low probability events have time to become real ones. What all of this means, taken together, is that a generation ship is an engineering problem with no clean solution. Every design choice involves trade-offs. Every improvement in one dimension creates a cost in another. More shielding means more mass. More redundancy means more mass. More agricultural area means more mass. More water means more mass. And the fuel required to accelerate all of that mass is itself mass that must be accelerated in a recursive calculation that spirals upward in a way that makes even seasoned aerospace engineers uncomfortable. The engineers who work seriously on these problems do not throw up their hands. They are too professional for that. Instead, they make choices. They decide which risks are acceptable and which are not, which systems warrant full redundancy and which can be allowed a single point of failure, which masses are justified and which must be cut. They optimize, iterating toward a design that is not perfect but is viable, a ship that could, in theory, keep people alive for 1,000 years. But here is what the engineering documents do not capture. Here is what the mass budgets and redundancy calculations and radiation exposure models leave out. The ship degrades, not catastrophically, not suddenly, but continuously, inevitably, over time. Metal fatigues under repeated stress cycles. Seals crack as materials expand and contract across thermal cycles. Bearings wear. Lubricants break down. Electronic components fail, one by one, at rates governed by the physics of semiconductor aging. Every system on the ship is running a kind of clock, counting down toward the moment when it will need to be repaired or replaced. On the first day of the voyage, every system is new. The redundancies are intact, the spare parts are stocked, the repair manuals are current, and the crew who wrote them are still alive to explain the subtleties. The ship is at its best. It will never be this good again. On the 100th year of the voyage, the systems are older. Some redundancies have been used. Some spare parts have been consumed. The repair manuals are being maintained by people who learned from the original crew, and each step of transmission has introduced small errors, small gaps, small misunderstandings that the original engineers would have caught immediately, but that the 10th generation of technicians does not know to look for. On the 500th year of the voyage, the ship is a different place. It has been repaired so many times that almost nothing original remains. Components have been replaced with components manufactured on board, which are not identical to the originals close enough to function, but subtly different in ways that accumulate. Materials have been recycled and reformed so many times that their properties have drifted from their original specifications. Systems that were designed to tolerance have had their tolerances quietly revised, in small ways, across generations, because the manufactured replacements could not quite match the originals. The ship still works. It must work, because if it does not work, people perish. But it works the way a very old building works, held together by the accumulated knowledge of everyone who has ever repaired it, carrying within its structure the history of every failure and every workaround and every improvised solution that kept it functional through 5 centuries of continuous operation. The people on board 500 years in have never known anything else. To them, this is simply the ship, the way it has always been, the way it will always be. They do not know what they do not know. They cannot compare their ship to what it was at the beginning, because they were not there at the beginning. They can read the original specifications, can study the design documents, can look at old recordings of the ship when it was new, but they cannot feel the difference the way an engineer who was there for the commissioning would feel it. And this gap between what the ship was designed to do and what the ship can actually do, between the original specifications and the current reality, grows every year, silently, invisibly, in the walls and circuits and recycled metals of a vessel traveling through the dark between the stars. There is one more category of failure that the engineering analyses tend to underweight, because it is the hardest to quantify and the easiest to dismiss as speculative, the catastrophic single-point failure, not the gradual degradation, not the slow accumulation of small problems, but the sudden, complete, irreversible collapse of a critical system with no warning and no time to respond. Imagine a structural failure in the primary hull, not a micrometeorite penetration, which is slow and detectable, but a catastrophic decompression, a seam giving way, a weld failing under fatigue stress that had accumulated for 300 years without triggering any sensor alarm. In seconds, a section of the ship is open to vacuum. The air rushes out at the speed of sound. The people in that section have no warning. They are simply there one moment and gone the next. Bulkheads seal, the breach is contained, the rest of the ship survives. But depending on which section failed, the losses could include irreplaceable personnel, the chief engineer, the chief physician, the master agronomist. The people whose knowledge cannot simply be read from a manual because it lives in the space between the lines of the manual, in the intuitions and judgment and experience that take a lifetime to build. Or imagine a cascading failure in the atmospheric processing system. A sensor gives a false reading, an automated response misinterprets the data. A corrective action is taken that makes the actual problem worse. By the time a human operator understands what is happening, the carbon dioxide levels in the inhabited sections have risen to the point where cognitive impairment has already begun. The people who need to solve the problem are already too impaired to solve it efficiently. The situation deteriorates faster than the response. These scenarios are not science fiction. They are engineering case studies. The history of complex systems, nuclear power plants, deep-sea installations, spacecraft is full of cascading failures that began with small, easily manageable problems and became catastrophes because of a combination of sensor error, human misinterpretation, and the unforgiving speed with which some physical processes unfold. On a generation ship, there is no outside observer to catch what the crew misses, no ground control with a different perspective, no rescue mission. The crew of a generation ship is simultaneously the only line of defense and the only resource available when that line of defense fails. The ship moves through the dark, the reactors burn, the water cycles, the crops grow, the air circulates, and somewhere in the vast mechanical complexity of a world in motion, something that has been weakening for decades finally gives way. This is not a question of if. Across 1,000 years, it is a question of how many times and how bad, and whether the people on board will have what they need to survive it. The answer to that question is not written in any engineering document. It is written in the people, and the people, their courage, their knowledge, their willingness to act and sacrifice and endure are the subject that comes next. There is a psychological experiment that was never formally conducted, but whose results we can infer from decades of accumulated research across disciplines as varied as prison psychology, polar exploration, submarine warfare, and the study of isolated religious communities. The experiment is simple in concept and devastating in implication. Take a group of people, put them in a confined space, tell them they will never leave. Not that they cannot leave right now, not that leaving will be difficult or expensive or dangerous, but that leaving is simply not a category of action available to them. The space they are in is the space they will always be in. The people around them are the people who will always be around them. The ceiling above them is the ceiling that will be above them until they close their eyes for the last time. Then watch what happens. The results, assembled from studies that approach this condition from different angles without ever fully replicating it, point in a consistent direction. Human beings can endure an extraordinary range of physical hardship, cold, hunger, pain, exhaustion, with remarkable resilience. But the removal of agency, the elimination of the possibility of change, the knowledge that the boundaries of your world are fixed and permanent, produces a specific kind of suffering that physical hardship alone does not. It is not depression in the clinical sense, though it often becomes that. It is something more fundamental, a kind of hollowing, as if the self, finding no horizon to orient toward, begins to turn inward and consume itself. This is the psychological reality that every person born on a generation ship would inhabit from their first breath to their last. To understand how this plays out across generations, you need to first understand the crucial distinction between the people who board the ship and the people who are born on it. The founding generation, the men and women who walked up the boarding ramp with the sky still above them and earth still beneath their feet, made a choice. Not an easy choice, not a choice without grief, but a choice nonetheless. They knew what they were leaving. They had weighed it against what they hoped to achieve, and they had decided. That decision, however painful its consequences, gave them something essential, a sense of authorship over their own lives. They were not passengers in someone else's story. They were the ones who had turned the first page. This matters psychologically in ways that are difficult to overstate. Research into the experiences of prisoners, of refugees, of people living under authoritarian regimes consistently identifies autonomy, the sense that one's actions shape one's circumstances, as one of the most powerful protective factors against psychological collapse. People can endure conditions that appear intolerable from the outside as long as they feel that they have some degree of agency within those conditions. The climber who chooses to spend a night on a freezing mountain ledge is not in the same psychological position as the person who is left there against their will, even if their physical circumstances are identical. The choice transforms the experience. The founding generation of a generation ship has that choice, however constrained. They selected themselves for this mission. They trained for it, prepared for it, said their goodbyes, and stepped on board with their eyes open. The suffering that follows is suffering they elected to accept. And that election, that act of self-determination, gives them a foundation that their children will not have. Their children are born into the ship. The ship is not something that happened to the founding generation's children. It is simply the world. It is what there is. And the question of whether they would have chosen it, had they been given the opportunity to choose, is not a question they can ever answer, because the opportunity was never given. It was settled before they existed. The decision was made for them by people they will come to know as parents, grandparents, ancestors, people they may love deeply, people whose sacrifice they may honor genuinely, but people who made a decision on their behalf that cannot be unmade. This is not a trivial philosophical point. It is a lived psychological reality that would shape every aspect of existence for every generation born on the ship after the first. Consider what it means to grow up in a world with no outside. On Earth, childhood is defined in part by an expanding horizon. The infant's world is the room, then the house, then the neighborhood, then the city, the country, the planet. Each expansion opens new possibilities, new identities, new futures. The child who grows up in a small town and moves to a large city at 18 is exercising a fundamental human capacity, the capacity to reinvent oneself by changing one's context, to become someone different by entering a different world. The child born on a generation ship cannot do this. The world does not expand. The corridors of the ship are the corridors of the ship. The hydroponic bays are where they are and will remain where they are. The observation deck offers the same view it offered on the day of departure and will offer the same view until arrival. There is no larger world waiting beyond the boundary of childhood. There is only the ship, in all its fixed dimensions, containing all the people there will ever be, all the possibilities there will ever be for a lifetime. Studies conducted on children raised in environments of severe geographic restriction, small island communities, isolated mountain villages, certain cloistered religious communities show consistent patterns of psychological adaptation. Children are indeed resilient. They adapt to their environment with a thoroughness that adults often cannot. The child who has never known a city does not experience the absence of a city as loss. The absence is simply normal. But this adaptability has a shadow side. Environments shape minds, and the mind shaped by a closed environment is not simply a mind that lacks certain experiences. It is a mind that has been formed by the specific pressures and constraints of that environment in ways that run very deep. The tendency towards suspicion of outsiders, the difficulty imagining alternatives to established norms, the psychological weight of being known completely and permanently by everyone around you with no possibility of reinvention, no possibility of starting fresh somewhere new. On a generation ship, everyone knows everyone. In a population of 10,000, you will encounter the same faces across your entire life. The person who wronged you when you were 12 will still be present when you are 60. The humiliations of childhood cannot be left behind in a hometown you never have to visit again. The failed relationships, the public embarrassments, the private shames they accumulate in a closed space with nowhere to go and no possibility of escape. Sociologists who study small, isolated communities consistently identify this dynamic as one of the most corrosive forces in social cohesion over time. Human beings need, on some level, the possibility of reinvention. We need to know that if things go badly enough in one context, we can leave and become someone different somewhere else. Strip that possibility away, and social pressure becomes something much heavier. Conformity is enforced not by explicit rules, but by the sheer density of mutual awareness. Everyone sees everything. Nothing is private. The cost of deviance, of being different, of dissenting, of failing publicly is extraordinarily high because there is no escape from the consequences. This brings us to one of the most carefully studied psychological phenomena in isolated environments, the dynamics of group conflict in conditions of permanent proximity. In 2019, a summary of research conducted on Antarctic winter-over cruise teams of scientists who spend the polar winter isolated at research stations with no possibility of evacuation identified a consistent pattern. In the first months, conflict is rare. The novelty of the experience, the shared sense of mission, the goodwill generated by mutual selection and preparation create a social atmosphere of cooperation and optimism. People are on their best behavior. They are aware that they are being observed, formally and informally, and they rise to the occasion. By the midpoint of the winter, the atmosphere has shifted. The novelty has worn off. Interpersonal irritations that were easily managed in the early months have had time to accumulate. Small resentments have calcified into firm opinions. Alliances have formed. Social hierarchies have been established and challenged and re-established. The psychological armor that everyone arrived with has been worn thin by months of enforced intimacy, and what lies beneath is not always pleasant. By the final months, the crews are typically functioning, the work gets done, the science continues, the station does not collapse, but the social texture has changed irrevocably. There are fractures. There are individuals who do not speak to each other. There are alliances and enmities that the participants will carry with them in some form for years after they return to the outside world. And these crews know they are going home. They know that the isolation ends. They can see the finish line, and they are moving toward it. Now remove the finish line. The Generation ship's founding crew has no finish line. Not for them. They will not live to arrive. They will live out their lives on board, and pass on board, and be buried or cremated or recycled on board, and the ship will continue without them. The finish line exists only for their descendants, in an abstract future that grows more abstract with every year that passes. What happens to group dynamics under those conditions is not something we have studied directly, because we have never put human beings in that situation. But we can extrapolate from what we know, and what we know suggests that the social pressures would be immense. The fractures that appear in Antarctic crews after 8 months would appear in Generation ship crews after 8 years, and they would not be healed by a flight home. They would need to be managed, contained, worked around for the rest of everyone's lives and the lives of everyone who came after. The psychiatrist and Holocaust survivor Viktor Frankl, writing in 1946 about his experiences in Nazi concentration camps, made an observation that has become one of the most widely cited insights in the psychology of survival under extreme conditions. He wrote that what determined whether a person survived psychologically, not just physically, was not the presence of pleasure or the absence of suffering, but the presence of meaning. People who could find a reason for their suffering, who could place their experience within a narrative that gave it purpose, were more likely to endure. People who could not, who experienced their suffering as random, purposeless, imposed without justification, were more likely to collapse. Frankl was not describing conditions identical to those of a Generation ship. The concentration camp was an environment of deliberate cruelty, not merely constraint, but the core psychological insight transfers. Human beings need their lives to mean something. We need to feel that what we are doing matters, that the suffering we endure is in service of something worthy, that the years of our lives are building towards something that justifies them. The founding generation of a generation ship can find that meaning. They chose to be there. They made a sacrifice for a reason. The reason is real to them, connected to living memory, to the world they left, to the hope they carry for the world ahead. The 10th generation has a much harder problem. They were born into the sacrifice. They did not choose it. The world that motivated the founding generation is centuries gone, accessible only through records and stories. The world that will justify the sacrifice, the destination, the new beginning is centuries ahead, visible only as a point of light in a telescope. These people live in the middle, in the long, undifferentiated middle of a journey that has no experiential beginning or end for them. They must find meaning in the middle. Some will find it in their work, in the knowledge that what they do keeps the ship alive, keeps the mission moving, keeps faith with the ancestors and with the descendants. Some will find it in their relationships, in love and family and friendship, in the small daily texture of a life fully lived within its constraints. Some will find it in the journey itself, in the extraordinary fact that they are crossing the void between stars, that no human being has ever done what they are doing, that they are, in some sense, the most remarkable travelers in the history of their species. But some will not find it. Some will look at their lives and see only walls, only recycled air and recycled water and recycled everything, a closed loop of existence that they did not choose and cannot leave, serving a purpose they did not agree to for beneficiaries they will never meet. And for those people, the question of meaning will not resolve. It will fester. The psychological literature on what happens when meaning cannot be found in a constrained environment is not comforting. Rates of clinical depression in isolated communities are consistently higher than in the general population. Alcohol and substance use, where available, increases. Risk-taking behavior increases, sometimes as a way of asserting agency in an environment where agency is limited, sometimes as a simpler form of self-destruction. Interpersonal violence increases, particularly in communities where there is no possibility of exit. The inability to leave a bad situation, a bad relationship, a bad social dynamic, a community that has turned hostile, is one of the most consistent predictors of escalating harm in the social science literature. On a generation ship, no one can leave. A person who is in a deteriorating marriage on Earth can separate, can move to a different neighborhood, a different city, a different country, can rebuild. On a generation ship, separation means continuing to live in the same enclosed space as the person you are separating from, encountering them in the corridor every day, seeing them in the hydroponic bay, hearing their voice through the walls. The space does not allow the distance that healing requires. A person who is bullied or ostracized or socially isolated on Earth can, eventually, find a different community. On a generation ship, there is only one community. If it rejects you, there is nowhere else to go. A person who is in conflict with the leadership, who disagrees with the direction of the mission, who wants to make changes that the established power structures resist, can on Earth seek allies outside the system, appeal to outside institutions, organize, protest, ultimately leave. On a generation ship, the system is total. There is no outside. Dissent has nowhere to go except inward or into confrontation with a power structure that controls the only habitat between you and the vacuum. These are not edge cases. These are structural features of any closed social system. They apply to prisons, to cults, to isolated communities throughout history. And the generation ship is all of these things simultaneously closed, total, inescapable for a duration that dwarfs any precedent in human experience. And yet, the ship must work. The people on it must function, must cooperate, must maintain the systems that keep everyone alive and the social structures that keep everyone sane. The mission depends not just on the engineering holding together, but on the human beings holding together. And human beings, as we have established, are not simple machines. They break in complex ways. They break quietly, invisibly, in the privacy of a mind that looks functional from the outside until the moment it does not. The question of how you keep 10,000 people psychologically viable across 1,000 years is not a question that has a clean answer. It is a design problem that bleeds into philosophy, into ethics, into the deepest questions about what human life requires in order to be worth living. Some of the structural responsibility in IFS. The ship must have mental health infrastructure, therapists, counselors, peer support systems, crisis intervention protocols. It must have spaces designed for psychological recovery, quiet rooms, spaces with varied sensory environments, places where a person can be alone in a way that the constant proximity of communal life does not otherwise allow. It must have cultural practices that provide regular moments of collective meaning, rituals, ceremonies, communal gatherings that remind people they are part of something larger than their individual suffering. But all of these are responses to a problem that cannot be fully solved. They are ways of managing an irreducible difficulty, and the managing must be done across generations, by people who are themselves subject to the same difficulty, who have never known anything different, who are trying to help others navigate a condition they share completely. There is a question that sits at the moral center of everything we have been discussing, and it is time to name it directly. The question is this: is it ethical to have children on a generation ship? Not is it necessary. We have already established that it is necessary, that the mission requires it, that without reproduction the ship becomes a tomb before it reaches its destination. The question is whether necessity is the same as ethics, whether the fact that something must be done makes it right to do it. The philosopher David Benatar has argued, in a context entirely unrelated to space travel, that bringing a person into existence is always, in some sense, an act that requires justification because it creates a being who will inevitably suffer without that being's consent for the entirety of whatever life follows. This argument is controversial. Most people reject it, on the grounds that life also contains joy, meaning love things that justify the suffering that accompanies them. Most people, most of the time, are glad to have been born. But the generation ship sharpens this question in a way that is difficult to dismiss. When you have a child on Earth, you are bringing them into a world of constraint and suffering, yes, but also of possibility, of open horizons, of the chance to choose a life, to reinvent themselves, to leave one context and enter another, to fail and recover and fail again and recover again. The suffering is real, but so is the agency. You are not simply condemning a person to a fixed existence. You are giving them a life that, however difficult, contains the structural possibility of self-determination. When you have a child on a generation ship, you are bringing them into a world with no outside, a world where the constraints are total and permanent, where the suffering is not an accompaniment to a life of possibility, but the defining condition of that life, where agency is real in small ways, but fundamentally circumscribed in the largest way possible. You cannot leave. You cannot choose your context. You cannot decide whether to participate in the mission that your existence serves. Is that child glad to have been born? Perhaps. Many of them will be. Human beings are astonishing in their capacity to find meaning and even joy in conditions that appear, from the outside, to offer neither. But the child does not get to decide. The decision is made for them by parents who have no choice but to make it, in service of a mission that requires it, inside a system that has already answered the question before the child exists, to ask it. This is not a comfortable place to sit. It should not be comfortable. The discomfort is the point, because here is what makes the generation ship different from every other dangerous or difficult mission in human history. A soldier who volunteers for a dangerous assignment accepts a risk on behalf of themselves. An explorer who sets out for an unknown continent accepts the dangers of the journey. A scientist who takes a posting in an extreme environment accepts the isolation and the hardship. These are all acts of individual consent, even when the consent is shaped by circumstances, by economic necessity, by social pressure. The generation ship asks for something different. It asks for consent on behalf of people who do not yet exist. It asks the founding generation to make a decision whose consequences will be borne primarily by their descendants, people who had no say in the matter, who were not consulted, who could not be consulted, because they did not exist at the time of the decision. This is not without precedent in human history. Parents make decisions on behalf of children all the time. Societies make decisions whose costs will be borne by future generations. Climate policy, public debt, infrastructure, all of these involve the present generation making choices that bind those who come after. We accept this as part of how civilization works. We cannot run all decisions by people who do not yet exist. But the generation ship is a more extreme version of this dynamic than anything we have previously attempted. The founders are not making a decision that will affect their descendants' lives in one area while leaving other areas open. They are making a decision that determines the entirety of their descendants' existence. Every aspect of every life that will be lived on that ship for 1,000 years flows from the founding decision. The descendants cannot undo it. They cannot adjust it significantly. They are born inside its consequences completely and permanently. And some of those descendants, in the middle of those 1,000 years, will look at the walls around them and understand with perfect clarity exactly what was done to them. There is a moment that appears, in various forms, in every serious account of long-duration isolation. It is not always dramatic. It does not always manifest as a breakdown or a confrontation or a visible crisis. Sometimes it is very quiet. A person sitting alone in a small room, looking at nothing in particular, and arriving at a thought that changes everything. The thought is this: I did not choose this. For a member of the founding generation, this thought is available, but incomplete. They chose to board the ship. They did not choose every consequence of that decision, but they made the decision. The thought has a counterweight. For the 5th generation, the 10th generation, the 20th generation, the thought has no counterweight. It is simply true, completely irrevocably true. I did not choose this. I was born here. I will pass here. I never had any other option. What a person does with that thought determines, to a significant degree, whether the ship survives. Some will let it pass, will acknowledge it, and move on, finding their way back to the smaller meanings that make daily life bearable: the work, the relationships, the modest pleasures available within the ship's constraints. This is not denial. It is a form of wisdom, the understanding that what cannot be changed need not be constantly resisted. Some will make it into a calling, will take the fact of their unchosen circumstances and transform it into a source of identity, even pride. We are the ones who carry this forward. We are the ones who hold the line between departure and arrival. We are not victims of this ship. We are its crew, its inheritors, its purpose. And some will be destroyed by it, quietly or loudly, or in the slow grey way that suffering often operates, not with drama, but with the gradual extinction of engagement, of interest, of the will to participate. These people are the ship's deepest vulnerability, not because they are evil or weak or insufficiently committed, but because they are human, because they arrived at a true thought: I did not choose this and could not find a way past it. The ship needs a response to these people that is neither dismissal nor punishment. It needs the psychological infrastructure to reach them, to offer them something genuine, to make the case for meaning in a way that does not require them to pretend the walls are not there. Whether it will have that infrastructure 200 years in, 300 years in, 500 years in, is not a question engineering can answer. It is a question about what kind of society forms inside a metal shell between the stars, what values it holds, what it is willing to do for its most vulnerable members, how it treats the people who cannot find their way to acceptance. That society is the subject we turn to next. Because a ship that stays structurally intact but collapses socially is not a ship that arrives, and social collapse on a generation ship does not look the way it looks on Earth. It looks quieter, more contained, more total, and by the time it becomes visible, it may already be too late to stop. In 1789, the crew of the British naval vessel HMS Bounty mutinied in the South Pacific. The story is well known in its broad outlines: the charismatic Fletcher Christian, the tyrannical Captain Bligh, the lure of Tahiti, the dramatic seizure of the ship. What is less well known is what happened afterward. 23 men, women and children eventually settled on Pitcairn Island, a remote volcanic outcrop in the southeastern Pacific, so isolated that it would not be officially rediscovered by the outside world for nearly 20 years. They brought with them the bounty itself, which they burned to prevent detection, a small supply of tools and seeds, and the accumulated cultural inheritance of late 18th century Britain and Tahiti. Within 4 years, all but one of the adult men were dead. They had killed each other. The dynamics that destroyed the Pitcairn community in those first years are disturbingly familiar to anyone who has studied the sociology of isolated groups. Resource conflicts, power struggles between factions with different interests, the absence of any neutral authority capable of mediating disputes, the physical impossibility of separation, and the specific corrosive chemistry that forms when human beings who cannot leave each other begin to accumulate grievances with no outlet. Pitcairn is not an allegory, it is a data point. A real community of real people, placed by circumstance into conditions that share several key features with a generation ship: radical isolation, limited resources, no possibility of external assistance, the permanent proximity of potential adversaries, and what it tells us is not reassuring. The community eventually stabilized. After the deaths, under the leadership of the sole surviving original mutineer, John Adams, who established a quasi-religious social order that held the remaining population together. When the outside world finally made contact in 1808, it found a small, functional community, proof perhaps that recovery is possible. But the recovery came after catastrophic violence, and it came through the establishment of a social order that was, by any reasonable standard, authoritarian. Adams was not elected. He was simply the last man standing, and the authority he exercised was unquestioned because there was no one left to question it. This is one model for how social order on a generation ship might stabilize after crisis. It is not the model anyone would choose at the outset. The governance problem of a generation ship is unlike any governance problem in human history, not because it is more complex than governing a nation or an empire, but because it operates under a combination of constraints that no previous society has faced simultaneously. The constraints are these. First, the society is closed. There is no immigration, no emigration, no possibility of external cultural influence except through the time-delayed signals arriving from an increasingly distant Earth. Whatever the society becomes, it becomes from within. Second, the consequences of governance failure are immediate and total. On Earth, a society can fail its members in profound ways and still persist because the members can leave, can form alternative communities, can survive outside the structures that have failed them. On a generation ship, the governance structure is the only structure. If it fails, there is no alternative. People cannot exit. They cannot form a rival community on the other side of the mountain. They are inside the failure, completely and inescapably. Third, the society must remain functional across timescales that dwarf the lifespan of any institution in human history. The Roman Empire, at its greatest extent, lasted roughly 5 centuries before fragmentation and collapse. The Catholic Church has maintained institutional continuity for roughly 2,000 years, but it has survived by evolving radically, by incorporating new populations and new ideas, by existing within and alongside other social structures rather than as the only structure in a sealed environment. The generation ship's governance system must function for 1,000 years inside a closed container, without the benefit of external inputs, without the possibility of the kind of radical reinvention that has allowed Earth's longest-lived institutions to persist. No human institution has ever done this. We do not have a model for it. We are speculating from first principles, guided by the patterns that history offers, and hoping that the patterns are informative enough to be useful. Begin with the founding generation's governance structure, because everything that follows is shaped by what they establish. The people who board a generation ship will almost certainly bring with them a governance framework developed on Earth, by people who have never experienced the conditions of the ship, designed to address problems that Earth-based designers could only imagine. This framework will reflect the values, assumptions, and blind spots of its creators, who will be, inevitably, people shaped by the political culture of their time and place, People who understand governance through the lens of nations and institutions and legal systems that have evolved over centuries to address the specific challenges of life on a planet with other options. The founding generation will implement this framework, adapt it, argue about it, revise it in light of experience. They are still close enough to Earth to have strong intuitions about what governance should look like, informed by living memory of how different systems have succeeded and failed. Their children will inherit a framework they did not design. They will have opinions about it, what should be changed, what should be preserved, what the founders got wrong, and what they got right. They will push for reforms. Some reforms will happen peacefully, others will be resisted, and in the resistance, the first fault lines of intergenerational governance conflict will appear. By the fifth generation, the founding framework will feel ancient. Not ancient in the way a revered tradition feels ancient with the weight of accumulated wisdom, but ancient in the way that arbitrary rules feel ancient. Rules whose original purpose has been forgotten and whose current enforcement feels like the exercise of power for its own sake. The fifth generation will ask why things are the way they are, and the answer, increasingly, will be because that is how they have always been, which is the answer that either stabilizes a social order through the weight of tradition or destroys it through the fury of the people who find that answer insufficient. The specific governance challenges that will emerge over time are not difficult to anticipate, even if their precise forms cannot be predicted. Consider the problem of expertise versus legitimacy. Running a generation ship requires technical knowledge of extraordinary depth. The people who maintain the atmospheric processes, the fusion reactors, the water recycling systems, the navigation computers, these people hold the lives of everyone on board in their hands every day. Their expertise is not theoretical, it is operational. A mistake in the reactor management system does not produce a bad quarterly report. It produces dead people. This reality creates an inherent tension in any governance system that attempts to be both technically competent and democratically legitimate. Technical competence argues for concentrating decision-making authority in the hands of people who actually understand the systems. Democratic legitimacy argues for distributing that authority across the population, giving everyone a voice in decisions that affect their lives. These two principles are not inherently irreconcilable. Modern democracies manage the tension through bureaucratic technocracy, regulatory agencies staffed by experts operating within democratically established frameworks. But on a generation ship, the tension is starker, the stakes higher, and the mechanisms for resolution more fragile. What happens when the Engineering Council makes a decision that the general population finds unacceptable? On Earth, you appeal to a higher authority, to the courts, to the legislature, to the press, to public opinion. On a generation ship, the Engineering Council may effectively be the highest authority on matters it claims as technical. Who overrules them? And if someone does overrule them, and they are wrong to do so, and the technical decision goes badly, people die. The inverse problem is equally dangerous. What happens when technical expertise becomes a vehicle for political control? When the people who control the critical systems use that control to consolidate power, to reward allies and punish opponents, to make themselves unaccountable? History is full of examples of technical or bureaucratic elites capturing governance systems and converting their expertise into entrenched privilege. In a closed system with no external check on power, this dynamic could become permanent within a few generations. The Polynesian navigators who settled the Pacific Islands offer a different cautionary tale from Pitcairn, and in some ways, a more instructive one. Between roughly 1500 BCE and 1000 CE, Polynesian seafarers accomplished one of the most remarkable feats of navigation in human history, crossing vast stretches of open ocean in double-hulled sailing canoes, guided by stars and currents and wave patterns, settling islands across millions of square miles of the Pacific. They developed sophisticated navigational knowledge, social structures capable of organizing long voyages, and cultural traditions that maintained the skills and values necessary for continued exploration across generations. And then, on many of the islands they settled, they stopped. The knowledge of long-distance navigation did not vanish overnight. It eroded, slowly, across generations, as the immediate need for it diminished, and the social structures that had transmitted it were replaced by structures oriented toward the very different challenges of settled island life. By the time European explorers arrived, many Polynesian communities had lost the navigational traditions that had brought their ancestors to those islands. The knowledge was not destroyed. It was simply no longer maintained, no longer valued, no longer passed down with the care and completeness that its preservation required. Easter Island, perhaps the most studied of the Polynesian settlements, offers the most extreme version of this story. The Rapa Nui people who settled Easter Island built a civilization of remarkable complexity, producing the famous Moai statues and developing a writing system Rongorongo that remains undeciphered. They also, over several centuries, deforested their island entirely in the process of building that civilization, destroying the ecological foundation that supported their population. By the time European contact occurred in 1722, the population had already collapsed. From a peak of perhaps 12,000 to a few thousand, the Moai had been toppled, and the Rongorongo script was known to only a handful of individuals who could no longer fully read it. The knowledge was still there, barely. The people who held it were still alive, barely. One more generation without intervention, and it would have been gone entirely. A generation ship is an Easter island that cannot afford to deforest itself. It is a Polynesian navigator society that cannot afford to forget how to navigate. The maintenance of critical knowledge is not optional, not something that can be allowed to slip over a few generations of declining interest. It is existential, and yet the mechanisms by which knowledge is lost, the slow diminishment of practice, the gradual displacement of expertise by other priorities, the death of the last person who truly understood something before they fully transmitted it, are exactly the mechanisms that operate in any human community over time. You cannot simply decide to remember. Memory is not a switch. It is a practice, maintained by use, degraded by disuse, dependent on a chain of transmission that can be broken at any link. The question of reproduction, which we touched on in the previous chapter, becomes a governance question as soon as it is recognized as a collective necessity rather than a private choice. On Earth, reproductive decisions are understood, at least in liberal democratic societies, as fundamentally personal. The state has an interest in population levels, but that interest is expressed through incentives and social support rather than direct control. You are free to have children or not, as many or as few as you choose, within the broad constraints of your circumstances. This freedom is considered a basic human right, connected to bodily autonomy, to the right to form a family, to the most intimate domain of personal life. On a generation ship, this freedom cannot be unlimited. The carrying capacity of the ship is fixed. The agricultural systems can support a certain population, and beyond that threshold, additional people mean less food per person, thinner margins, higher risk of catastrophic shortage. The water recycling systems have a throughput limit. The living space is finite. The genetic health of the population requires not just a minimum number of births, but a specific distribution of genetic material across those births, certain pairings encouraged, others discouraged, to maintain diversity and prevent the accumulation of harmful mutations. Someone must make these decisions. Some governance body must determine, each year or each decade, what the acceptable range of population growth is, how many births the ship can sustain, which genetic combinations are medically advisable, and what happens when people make choices outside those parameters. There is no version of this that does not involve the state, whatever form the ship's governance takes, in the most intimate domain of human life. The fairest version, perhaps, involves a lottery system, a certain number of birth permits issued each year, distributed randomly among qualified applicants. Random distribution avoids the explicit value judgments of a merit-based system, eliminates the worst forms of favoritism, and gives everyone an equal theoretical chance at parenthood. But it also means that people who want children desperately may wait years, while people with no particular interest in parenthood may win permits they did not prioritize. It is fair in the mechanical sense, without being satisfying in the human sense. The worst version involves the governance structure, making explicit judgments about who is genetically, psychologically, or socially fit to reproduce. This is eugenics, the word that carries with it the weight of the 20th century's worst crimes, and calling it something else: genetic health management, population optimization, reproductive responsibility does not change what it is. The history of eugenics on Earth is a history of the most vulnerable populations being subjected to the reproductive preferences of those in power, dressed in the language of science and collective benefit. And yet, on a generation ship, some version of genetic management is genuinely necessary, not because of ideology but because of mathematics. A closed population of 10,000 individuals reproducing without attention to genetic diversity will experience measurable inbreeding depression within a few generations. Harmful recessive mutations will spread. The health of the population will decline. Without intervention, the long-term viability of the mission is compromised. The generation ship forces a confrontation with this tension that Earth-based societies have managed to avoid by having large enough populations that genetic diversity manages itself. On the ship, it cannot manage itself. It must be managed, and the governance body tasked with managing it will wield power over the most fundamental aspect of human existence. Whether that power is exercised wisely, humanely, and with adequate accountability across 1,000 years is not a question that can be answered in advance. It is a question that will be answered, or not answered, in the daily decisions of people under pressure, in institutions that may have drifted far from their founding principles, in a society that has been shaped by 1,000 years of closed-loop existence into something that the founders might not recognize. Cultural drift is inevitable. This is not a prediction based on pessimism about human nature. It is a statement about how culture works. Culture is not a fixed object. It is a living process, maintained by continuous practice and transmission, shaped by the experiences and challenges of the people who carry it, responsive to the environment it operates in. Change the environment and the culture changes. Change it radically, seal it inside a metal container, remove all external inputs, subject it to a millennium of completely novel pressures, and the culture will change radically. The language spoken on the ship will drift. This is not speculative. It is what languages do. In the absence of contact with a stabilizing external standard, languages change at rates that make them unrecognizable within a few centuries. The English of 1025 is incomprehensible to modern English speakers. The English of the generation ship's founding will be equally incomprehensible to the English of the ship's 10th generation, if it is still called English at all. This matters more than it might seem, because the ship's critical knowledge, the technical manuals, the engineering specifications, the medical protocols, the navigational calculations is encoded in the language of the founding generation. As that language drifts, the distance between the living language of the ship and the language of the technical documents grows. Instructions that were clear become ambiguous. Terminology that was precise becomes vague. Concepts that were well-defined become fuzzy. At some point, reading the original technical documents becomes a specialized skill, like reading medieval Latin, possible but requiring dedicated study. And if the people with that skill are not numerous enough, not valued enough, not consistently produced by the educational system, the documents become effectively inaccessible. Values drift in more complex ways and with more unpredictable consequences. The founding generation carries with it the values of its originating culture, the ethical frameworks, the political commitments, the aesthetic sensibilities, the conceptions of justice and dignity, and the good life that shaped them on Earth. These values will inform the ship's initial governance structures, its educational system, its cultural practices. But values are not transmitted intact across generations. They are reinterpreted, renegotiated, reshaped by each generation's experience. The values that made sense in the context of early 21st century Earth will not automatically make sense in the context of life on a ship 300 years into an interstellar voyage. Some will persist because they speak to permanent features of human nature. Others will fade because the conditions that made them salient no longer apply, and entirely new values will emerge. shaped by the specific challenges and possibilities of ship life that the founding generation could not have anticipated. This is not necessarily bad. Cultural evolution is how human societies remain adapted to their circumstances. A culture that cannot change is a culture that will eventually be destroyed by the gap between its fixed values and its changing reality. The capacity for cultural evolution is a feature, not a bug, but on a generation ship, cultural evolution poses a specific danger. The mission's success requires certain commitments to be maintained across 1,000 years. Commitments to the technical systems, to the governance structures, to the reproductive management protocols, to the destination itself. If cultural evolution leads the ship's society away from those commitments, the mission fails, and there is no external authority to prevent the drift, no outside check on the direction of cultural change. Consider the destination itself as a cultural object. For the founding generation, the destination is real. It is a place chosen after careful deliberation, associated with specific hopes and specific people and specific decisions that living members of the community made and remember making. The destination has texture, history, emotional weight. For the 10th generation, the destination is a story, a very important story, the central story of their civilization, but a story nonetheless. It exists in records, in commemorations, in the annual rituals that mark the anniversary of departure and the projected anniversary of arrival. It is not a lived reality, it is an inherited narrative. For the 20th generation, the destination is mythology. The founding generation are figures from a distant past, as remote as the founding fathers of a nation or the prophets of a religion. Their decisions carry authority not because they are remembered firsthand, but because they are encoded in the structures of the society, in the governance documents, the educational curriculum, the ceremonial calendar. The destination is the promised land, and like all promised lands, it has become as much a symbol as a place. There is nothing wrong with this transformation. Myths and symbols are how human societies maintain commitment to long-term projects. The question is whether the myth remains functional, whether it continues to motivate the behaviors necessary for the mission's success, or whether it becomes decorative, a ceremonial shell that has lost its capacity to organize action. And the answer to that question depends on what happens in the middle generations, not the founding generation, which is close to the source, not the arrival generation, which is close to the destination, but the generations in between, for whom the voyage is simply life, for whom the destination is simply a story, and for whom the question of meaning must be answered, not by inherited narratives, but by whatever the ship's culture has become by that point. There is a darker possibility that deserves direct address. What if the mission drifts not accidentally but deliberately? Not through the gradual, unconscious processes of cultural change, but through a conscious decision by a generation that looks at the constraints imposed by the mission and decides they are no longer willing to accept them. This is not an irrational position. It is, in some ways, the most rational position available to people who did not choose their circumstances. A generation born 400 years into the voyage, looking at another 600 years of the same existence, might reasonably ask, why? Why are we doing this? Who decided that this destination, chosen by people who have been gone for 4 centuries, is worth another 6 centuries of sacrifice? What authority do the dead have over the living? These are not questions that can be dismissed. They are the questions that any free society asks of inherited obligations. The difference on a generation ship is that the answer to these questions has operational consequences that cannot be separated from the physical survival of everyone on board. If a generation decides to abandon the mission to stop decelerating toward the destination, to alter course toward some closer object, to simply drift, the consequences are not merely political, they are physical. The ship's systems were designed around a specific mission profile. Deviation from that profile creates technical challenges that compound over time. A ship designed to decelerate and enter orbit around a specific star, diverted to a different trajectory by a generation that rejected the original mission, may not be capable of executing whatever new mission they have chosen for it. The founding generation built the ship to go somewhere specific. If their descendants decide to go somewhere else, or nowhere at all, the ship may not cooperate. And then there is the possibility that haunts every serious analysis of generation ship governance, the failure mode that is both the most likely and the hardest to design against. Not dramatic rebellion, not sudden collapse, not the violent overthrow of one system by another. Gradual erosion, the slow accumulation of small failures, the governance structure that becomes slightly less responsive each decade, slightly more focused on the interests of those in power, and slightly less on the welfare of everyone else. The educational system that transmits slightly less knowledge each generation, that produces graduates who are slightly less capable than their predecessors, that loses slightly more of the technical depth that the mission requires. The social cohesion that frays a little more each year, that produces a little more resentment and a little less willingness to cooperate, that makes the daily work of keeping the ship alive a little harder and a little more contested. None of these failures is individually catastrophic. Each one is manageable. Each one can be explained away, rationalized, absorbed into a narrative of a society that is basically functional, basically on track, basically fine. But they compound. After 100 years of gradual erosion, the governance structure is noticeably less functional than it was at founding. After 200 years, it is significantly less functional. After 500 years, it may be a shadow of what it was designed to be, staffed by people who have inherited its forms without its substance, maintaining its rituals without understanding their purpose, exercising its powers without feeling their weight. This is how institutions die on Earth, when they die quietly. Not in a dramatic collapse, but in a long twilight of diminishing capacity, of forms persisting after substance has departed, of people going through motions they no longer fully understand, in service of purposes they no longer fully believe. On Earth, institutional death creates space for replacement. New institutions emerge. Other social structures absorb the functions that the dying institution no longer performs. The society reorganizes. It is painful, sometimes violent, sometimes unjust, but it is possible. On a generation ship, there is no replacement. There is only what is there. And if what is there is a governance structure, in the late stages of erosion, a technical knowledge base that has thinned to dangerous fragility, a social fabric that has frayed past the point of easy repair, then what is there may not be enough. The ship continues to move through the dark. The stars do not know or care. The destination grows imperceptibly brighter, year by year, decade by decade, century by century. And inside the hull, in the recycled air and the artificial light, something that was meant to last 1,000 years may already be beginning to fail. Not catastrophically, not visibly, just quietly, slowly, in the way that things fail when no one is watching closely enough, or when the people who are watching have forgotten what they are supposed to be watching for. And yet the ship must go on, because there is no other option. There is only forward, only the destination, only the long commitment made by people long dead to a future that belongs to people not yet born. The society on board will make mistakes. It will suffer crises. It will lose knowledge and recover some of it, and lose more. It will produce leaders who are wise, and leaders who are corrupt, and leaders who are simply insufficient to the scale of what they have been asked to manage. It will experience violence and healing and transformation and loss and the strange, persistent, unkillable human capacity for finding meaning in the most constrained and difficult circumstances. It will, in some form, endure. Whether what endures is recognizable as the civilization that departed, whether the people who eventually arrive carry forward anything essential from the world that launched them, is a question that cannot be answered until the moment of arrival. And the moment of arrival, when it comes, will not be what anyone imagined. Not the founding generation in their careful planning, not the arrival generation in their inherited stories, not anyone in the long middle who tried to imagine what it would feel like to finally stop moving and stand on solid ground under an open sky for the first time. Because nothing about a 1,000-year voyage can be fully imagined in advance, and nothing about arrival can be fully prepared for. The destination is approaching, but the people approaching it are not the people who set out. And the world waiting for them is not the world anyone planned for. 1,004 years after departure, the star is no longer a point of light. It fills the observation deck with a warmth that no one on board has ever felt from a star before. Not the cold, indifferent gleam of background stars, unchanged across centuries of travel, but a genuine radiance, directional, warming, growing slightly brighter each week as the ship completes the final arc of its deceleration. People gather on the observation deck in shifts, standing in silence, looking at the light. Some of them weep. Most do not know exactly why. They have heard about this moment their entire lives. Every generation before them heard about it, told their children about it, built rituals around the anticipation of it. The moment when the destination star becomes something you can feel on your skin rather than simply see with your eyes. The moment that marks the end of the long middle, the beginning of the end of the journey that began 1,000 years ago with people none of them ever knew. But the people standing on the observation deck are not celebrating. Not yet, not until they know what is waiting for them. The ship's long-range sensors have been gathering data on the target planetary system for decades. From several light-years out, the resolution was poor, broad spectroscopic signatures, rough estimates of planetary mass and orbital parameters, general indications of atmospheric composition. But as the ship decelerated and drew closer, the data improved. Pixel by pixel, measurement by measurement, the destination resolved from an abstraction into something approaching a real place. What the sensors showed was, in most respects, consistent with what the founding generation had hoped. The second planet of the system, the one designated in the founding mission documents as Primary Target Alpha, a name that has been translated, abbreviated, mythologized, and finally reduced by 1,000 years of linguistic drift to something that sounds nothing like its original form, sits at the right orbital distance from its star. Spectroscopic analysis confirms oxygen in the atmosphere, in concentrations sufficient to sustain human respiration without supplementation. Surface temperatures, averaged across the planet's day-night cycle and seasonal variation, fall within the range that human physiology can tolerate without mechanical assistance. There is liquid water on the surface. There is weather. By every measure available to instruments observing from space, the planet is habitable. But instruments observing from space cannot see everything, and the generation that is about to attempt a landing knows, with a clarity that their ancestors could only theorize, exactly how much the instruments do not show. Begin with the human beings themselves. The people on board this ship, in this final year of the voyage, are not the same as the people who departed, not in any biological sense. They are the product of 1,000 years of life, in conditions that Earth never prepared the human body to inhabit, and the body, given enough time and enough pressure, responds to its conditions. Bone density is the most visible problem. Human bone is a dynamic tissue, continuously remodeled by the mechanical stresses placed upon it. Walk on Earth, and your skeleton is subject to the full force of one gravity, every moment of every day. Your bones are built by this stress, maintained by it, dependent on it. Reduce the gravity and the bones thin. This is well established by decades of research on astronauts aboard the International Space Station, where residents in microgravity lose bone mass at rates of roughly 1 to 2% per month without aggressive countermeasures. The generation ship does not operate in microgravity. Its rotating habitats produce an effective gravity through centrifugal force, and the designers set the rotation rate to approximate Earth's gravitational pull as closely as possible. But approximately is not exactly, and even small deviations, sustained across a lifetime, accumulate into measurable changes in skeletal structure. The people on board have slightly different bones than their ancestors had, adapted to a slightly lighter effective gravity, thinner in some dimensions, shaped differently in others. When they stand on the surface of a planet with full gravity, their skeletons will notice. This is not immediately disabling. Human beings are adaptable. The body will adjust, given time, to a stronger gravitational environment. But the adjustment is painful, and the time it takes depends on how different the new gravity is from what the body has adapted to, and how old the person attempting the adjustment is. A young adult, physically healthy, can adapt to increased gravity within months. An older person, whose bones have been shaped by a lifetime of reduced gravity, may never fully adapt. The process may be permanently uncomfortable, chronically painful, accompanied by an increased risk of stress, fractures, and joint problems that will not resolve on their own. The generation that arrives is a generation that has never in its life experienced what it is about to experience. Cardiovascular adaptation is a second problem, subtler but potentially more dangerous. The human heart is a pump, and like all pumps, it sizes itself to the load it must manage. A heart that must pump blood against the full force of Earth's gravity, keeping circulation adequate in a body that stands upright and moves through the world, develops a certain capacity. Reduce the gravitational load slightly across many generations, and the cardiovascular system adapts to the reduced demand. Not dramatically, the adaptation is gradual, distributed across many individuals, across many generations, shaped by the complex interplay of genetics and environment that governs all physiological change. But measurably, the people stepping off the ship onto a full gravity planet will be asking their cardiovascular systems to perform at a level those systems have not been fully selected for across 1,000 years of slightly reduced demand. Most will manage. The young, the fit, the genetically fortunate will adapt without crisis, but the margins will be thinner than they would be for a person whose ancestry includes 1,000 years of Earth normal gravity. And on a planet with no hospital capable of managing cardiac complications, thin margins are dangerous. There are other physiological questions whose answers are genuinely unknown because we have never done this before. What happens to an immune system shaped by 1,000 years of the ship's specific microbial environment when it encounters the microbiome of an alien planet? The ship's closed ecology will have evolved its own stable community of microorganisms, the bacteria, fungi, and viruses that inhabit the air, the surfaces, the bodies of the people on board. Over 1,000 years, the ship's human population and its microbial population will have reached a kind of equilibrium, a mutual adaptation that is invisible in daily life, but real at the level of immunology. The planet's microbiome will be entirely different. Not just unfamiliar in the way that a new country's microbiome is unfamiliar, producing a few days of digestive discomfort before the system adjusts, but genuinely alien, built from biochemical foundations that may or may not be compatible with human biology in ways we cannot predict from orbit. The colonists will get sick, this is certain. The only question is how sick, and from what, and whether the ship's medical resources adapted over 1,000 years to the specific health challenges of ship life will be adequate to address illnesses caused by organisms that have never been studied, never been cultured, never been treated. The ship's pharmacological stores will have evolved over the voyage. Medicines brought from Earth will have been supplemented by medicines manufactured on board, drawing on whatever biochemical knowledge the ship's medical tradition has maintained. But the knowledge base was built for the ship's microbial environment, not for an alien one. The colonists will be asking a medical system to treat conditions it has never encountered, using tools designed for a different world. Some will die. This is not pessimism. This is the historical pattern of every major encounter between human populations and new microbial environments. The settlement of the Americas by European colonists, whatever its other dimensions, demonstrated with devastating clarity what happens when human immune systems encounter pathogens they have no history with. The generation ship colonists will be on the other side of that equation, the newcomers, arriving without immunological preparation into a world whose biological residents have had 1 billion years to develop their defenses. And then there is the question of what the planet actually looks like when they get close enough to see. The sensors said habitable. The sensors measure temperature, atmospheric composition, the presence of liquid water, the rough features of planetary geology, what the sensors cannot measure, at least not with the technology available to a ship that has been traveling for 1,000 years, maintaining its instruments across generations of use and repair and improvisation, is the texture of habitability. Is the oxygen in the atmosphere produced by photosynthesis, by living organisms whose presence implies a biosphere of some complexity? Or is it abiotic, the product of geological or photochemical processes that require no life? The answer matters enormously. An oxygen-rich abiotic atmosphere suggests a planet that is chemically friendly to human life, but biologically empty. No ecosystems to disrupt, no native pathogens to encounter, but also no native biology to study, no organic chemistry to leverage, no living planet to become part of, a lonely world that humans can inhabit but cannot partner with. An oxygen-rich biotic atmosphere suggests a living planet, a planet with ecosystems, possibly with complex ecosystems, possibly with ecosystems that have been producing oxygen for hundreds of millions of years, which means they are old and complex and thoroughly entangled, which means the arrival of humans will be a disturbance on a scale the planet has never experienced. We have faced this question in a theoretical form when discussing Mars colonization and the possibility of contaminating a sterile Mars with Earth organisms. On Mars, the debate is hypothetical because we have found no evidence of life. At the generation ship's destination, the answer may not be hypothetical. The answer may be visible from orbit, green or brown or some alien color across the continental surfaces, the unmistakable signature of biology at work. And if it is visible from orbit, if the planet is alive, then the people in the ship above it face a question that the founding generation encoded in their mission documents as a theoretical, ethical consideration, but that the arrival generation must answer as an immediate practical one. Do they land? This question will not be answered easily. It will not be answered unanimously. And the disagreement it produces will be the first major governance crisis of the arrival, the moment when a society that has been held together for 1,000 years by the shared project of getting here must now decide what here means and what rights it grants them. Some will argue that the mission is clear. The founding documents specify settlement. The planet is habitable. The colonists have traveled 1,000 years and sacrificed everything. They are not tourists. They are not explorers conducting a survey. They are settlers, and the planet is where they are meant to settle. The presence of native life is a complication, not a prohibition. Every planet with complex life has native organisms that will be displaced or affected by human settlement. That is what settlement means. It has always meant that. And the alternative, turning back after 1,000 years, is not an alternative. Others will argue that the founding generation did not know the planet was alive when they chose it, that the discovery of life changes the ethical calculus in ways that override the original mission parameters, that you cannot claim the right to colonize a living world simply because your ancestors set out toward it in ignorance of what they would find, that the existence of life, even microbial life, even life that bears no resemblance to anything human, creates obligations, that the mission documents, written by people who never imagined this specific situation, cannot address. Both arguments are serious. Both are made by serious people, and neither can be fully resolved by appealing to authority, because the authority, the founding generation, Earth itself, any institution capable of adjudicating the dispute, is either dead or so far away that its opinion will not arrive for 1,000 years. The ship's governance structure will make a decision. It must. The ship cannot remain in orbit indefinitely. The systems are degrading. The population needs land. The decision will be made, and it will be contested, and the contest will leave fractures in the social fabric that the colony will carry into its first years on the ground. But all of this assumes that the planet is what the censors said it was. There is another possibility that deserves its own silence, its own weight, its own place in the accounting of what a generation ship voyage might actually cost. The planet is not habitable, not subtly less hospitable than anticipated, not habitable with adjustments and medical support and careful management of the colonists' exposure to native biology. Genuinely, fundamentally uninhabitable. The atmospheric composition that looked like oxygen from a distance is something else, something that the founding generation's spectroscopic instruments, operated at extreme range by people working with the best available technology of their time, read incorrectly, or the surface temperature measurements were averages that concealed extremes lethal to human physiology, or the liquid water on the surface is a brine so chemically hostile that contact causes immediate biological damage, or the surface is subject to a radiation environment that the atmosphere does not adequately shield, not because of a high-energy star, but because of a peculiarity of the planetary magnetic field that could not be detected from the distance at which the original observations were made. Any of these errors is plausible. All of them are consistent with the limits of remote sensing at interstellar distances. The founding generation was not negligent. They were working at the edge of what was knowable, making decisions under conditions of irreducible uncertainty, accepting that some of what they believed about the destination might be wrong. But the people who arrive are the ones who live with the wrongness. They have traveled for 1,000 years. They have exhausted the ship's fuel reserves in deceleration. There is no longer enough propellant to mount a significant change of trajectory, let alone a return voyage. They are in orbit around a planet they cannot land on, in a ship that was not designed for permanent habitation, and that has been degrading for a millennium. The fuel is gone. The destination is closed. The backup plans written into the founding mission documents, contingency scenarios developed by people who could not have predicted exactly this situation, may or may not be adequate to the reality now facing the arrival generation. There may be other planets in the system, less promising, requiring more adaptation, demanding more from the colonists in exchange for less. The governance structure must evaluate them, must make decisions about which risks are acceptable, must organize a population that has spent the last weeks learning that the thing they traveled 1,000 years to reach was not what they were promised. The psychological impact of this discovery on a population that has maintained its cohesion across a millennium of sacrifice, precisely because the destination was real, the promise was real, the end of the journey was real, is not difficult to imagine. It is the worst kind of loss, the kind that comes after everything else has already been given. And there is one more possibility, the one that is perhaps the most purely cruel, because it contains no tragedy of ignorance, no failure of planning, no inadequacy of technology, only the unstoppable passage of time. Imagine that the ship arrives, and the planet is exactly as hoped, habitable, beautiful, even by alien standards, ready to receive its colonists, scarred by whatever geological and biological history it carries, but fundamentally open, fundamentally adequate to the needs of a small human community, with the will to build something new. And in orbit, already, is another ship, not alien, human, from Earth. The founding generation departed 1,000 years ago, when the fastest propulsion technology available could accelerate a ship to approximately 1% of light speed. But 1,000 years is a long time. Earth did not stop. Earth continued. Its scientists continued. The problems of propulsion that seemed intractable in the founding generation's era were not intractable forever. Perhaps 200 years after the generation ship's departure, a breakthrough was achieved. A fusion drive capable of reaching 5% of light speed. Perhaps 400 years after departure, another breakthrough. A drive capable of 10%. Perhaps 600 years after departure, something even more remarkable, a propulsion system that the founding generation could not have imagined, that compresses the travel time from centuries to decades. The generation ship has been traveling for 1,000 years at 1% of light speed. A ship launched 500 years after it, traveling at 10% of light speed, would overtake it and arrive at the destination 500 years earlier. The people in orbit above the habitable planet, looking down at the colony that has already been established, the infrastructure that has already been built, the civilization that has already taken root in the centuries since the fast ship arrived, these people are not pioneers. They are not the first. They are not the reason Earth sent out into the dark. They are a relic, a vessel from a forgotten era, carrying people shaped by 1,000 years of isolation, arriving to find that the world they were sent to claim has already been claimed by their own species, by people who stayed home until the technology was ready, by people who arrived without sacrifice, without the deaths of 30 generations, without 1,000 years of closed-loop existence that remade their bodies and their culture and their language into something their Earth ancestors would not fully recognize. Is this failure? In the narrow sense, no. The mission achieved its objective. The destination was reached. Human presence was established, but the cost, the unimaginable cost. The generations who lived and passed in transit, the children born into metal corridors who never saw a sky, the social structures that frayed and reformed and frayed again across a millennium, all of it rendered not necessary by the simple fact of technological progress. The founding generation could not have known this would happen. They made their decision with the information available to them in the full and honest belief that what they were doing was the only way. They were not wrong, given what they knew. But what they knew was incomplete, because knowledge is always incomplete, because the future is always opaque, because the decision to send a generation ship requires betting not just on the destination but on the technological stasis of the civilization left behind. And civilizations do not stagnate, they advance. The arrival generation stands at the threshold of whatever comes next. Below them, or around them, or ahead of them, the planet, or the ruins of their hope, or the evidence of their obsolescence. Behind them, 1,000 years of sacrifice that cannot be undone and cannot be adequately honored by anything that follows. They are different from the people who departed, not just physiologically, not just culturally, not just linguistically. They are different in a way that runs deeper than any of these specific changes. They are people shaped by an experience that no other human beings have ever had, the experience of being born into a commitment they did not make, of living inside a purpose that predated them and would outlast them, of existing in the long middle of something that their ancestors began and their descendants would complete. That experience made them something specific, something that does not translate easily into the categories available to people who live their whole lives on a planet, under an open sky, with the option to leave. It made them patient. Not the patience of people who have accepted their circumstances and found peace with them, though some of them found that too, but the patience of people who have learned, through the accumulated testimony of 30 generations, that the only time available is the present moment, that the destination is always ahead and the departure is always behind, and that the only thing a person can actually do is the work that is in front of them, today, in the recycled air and the artificial light, with the people they have. That patience is not nothing. In a universe as large and as indifferent as ours has turned out to be, the capacity to endure without losing the will to arrive is not a small thing. It may, in the end, be the only thing that gets anyone anywhere at all. The planet waits. The sensors continue their patient cataloging of its surface. The ship's systems, degraded and repaired, and degraded again across 1,000 years of continuous operation, continue to function, barely, adequately, sufficiently. And the people tired, changed, shaped by a journey none of them chose and all of them completed, look down at the light, reflected off an alien atmosphere, and they feel something that does not have a name in the language of their ancestors. Something between arrival and beginning, between ending and start. The feeling of standing at the edge of something enormous, knowing that whatever comes next will be determined not by the people who sent you here, not by the people who are not yet born, but by you, in this moment, with what you have, which is not much, but which is, perhaps, enough. Come back, for a moment, to where we began. 25 trillion miles, the distance to the nearest star, a number that means nothing until you sit with it long enough to let it mean something, until you stop treating it as a figure on a page and start treating it as what it actually is, a measurement of the universe's fundamental indifference to human ambition. The stars are not waiting for us. They are not hostile to us. They simply are, at distances that our fastest vehicles would require tens of thousands of years to cross, burning their fuel on timescales that make the entire history of human civilization look like a brief flicker, entirely unaware that on one small world orbiting one ordinary star, a species that has existed for less than a cosmic eye blink has begun to look up and wonder how to reach them. We have spent this journey examining one answer to that question, not the elegant answer, not the answer that science fiction prefers, not the answer that involves a breakthrough technology that dissolves the tyranny of distance in a single stroke, the brutal answer, the answer that does not cheat, that does not borrow from physics we do not yet possess, that looks at the numbers as they actually are and asks, given this, given these distances and these velocities and these timescales, what would it actually take? The answer is people. generations of them, entire lifetimes, offered up to the dark between the stars, in service of a destination that most of them will never see. We have followed the logic of that answer, wherever it leads, and it leads to uncomfortable places. It leads to children born into closed metal corridors who will spend their entire lives inside a machine, who will never feel wind or stand under open sky or have the option of leaving. It leads to governance structures that must somehow remain functional and humane across timescales that have broken every institution in human history. It leads to reproductive policies that reach into the most intimate domain of human life and subject it to collective management. It leads to the slow erosion of language, of culture, of technical knowledge, of the very identity that the founding generation carried on board and hoped to transmit intact across 1,000 years of closed-loop existence. It leads to arrival, which is not triumph, but threshold, not conclusion, but beginning of a new set of problems that the 1,000-year voyage has left the colonists imperfectly equipped to face. And it leads, in the most honestly uncomfortable version of the story, to the possibility that all of it, every birth and every death and every generation of sacrifice, might have been rendered unnecessary by a civilization that stayed home and kept working on the problem until it found a better answer. These are not comfortable conclusions. They were not meant to be. The generation ship is not a comfortable idea. It never was. But here is what I want you to hold alongside the discomfort. Somewhere in the middle of a 1,000-year voyage, in a year that has no special significance in the founding mission documents, in a generation that will receive no particular recognition from the histories written after arrival, a child is born on board the ship. She grows up in the only world she will ever know. She learns the ship's rhythms the way you learn the rhythms of your childhood home, not as knowledge but as instinct, as the felt texture of normalcy. She knows which corridor smells of the hydroponic bays and which smells of the engineering section. She knows the sound the atmospheric processors make at night, a low harmonic resonance that she has heard every night of her life and that she finds, despite knowing exactly what it is, deeply comforting. She becomes a technician, atmospheric systems. It is the role the ship needs her to fill, and she fills it with a competence that her supervisors recognize and her colleagues depend on. She spends her days in the maintenance spaces behind the living areas, in the narrow access corridors where the recyclers and processors live, keeping the air breathable, keeping the chemistry balanced, keeping the invisible infrastructure of survival running with the quiet diligence that 1,000 years of ship life has made into something close to sacred. She has relationships. She loves and is loved, imperfectly, in the way that all love is imperfect, in close quarters over long years. She has children, 2 of them, born into the same ship she was born into, inheriting the same corridors and the same recycled air and the same distant destination that she inherited from her parents who inherited it from theirs. She never thinks about meaning, not in the abstract way that word is typically used. She does not sit in the observation deck and contemplate the significance of her existence against the backdrop of the cosmos. She does not compose philosophical meditations on the ethics of generational sacrifice or the metaphysics of inherited obligation. She thinks about the pressure variance in the secondary recycler. She thinks about whether her daughter, who is 12 and shows a talent for mathematics that no one else in the family has displayed, should be encouraged toward navigation rather than engineering. She thinks about the friend she argued with last week and whether the argument needs to be repaired and how to repair it without losing the point she was trying to make. She thinks about the small, specific, textured contents of a life that is fully real to her, fully hers, fully worth living in the only terms that matter, the terms of the person living it. She passes at 63 from a cardiac event that the ship's medical team works hard to prevent and cannot. The atmospheric processors continue to function without interruption because she trained her replacement well, because she understood that the knowledge in her hands was not hers to keep but hers to transmit, because she grasped, without ever articulating it in these terms, that her life was one link in a chain that required every link to hold. Her name is not in the histories. The founding documents do not mention her. The arrival generation, stepping off the ship onto alien soil 400 years after her death, does not know she existed. but they breathe. Because of her, and the 1,000 others like her in her generation, and the 1,000 others in every generation before and after, they breathe. This is what the generation ship actually is, stripped of the engineering specifications and the governance debates and the philosophical arguments about consent and obligation and the ethics of bringing children into closed systems. It is a chain of people, each one holding a link that connects the departure to the arrival, the founding to the completing, the dream of the people who looked up at the stars and said, "We should try to go there," to the reality of the people who finally do. The chain is not romantic. It is not made of heroes. It is made of ordinary people doing the work that is in front of them, day after day, generation after generation, in circumstances they did not choose and cannot change, holding their link with whatever combination of commitment and resignation and love and frustration and simple habit they can manage. Some links are stronger than others. Some are forged by people of extraordinary character who understand with perfect clarity what they are part of and embrace it fully. Some are held together by people who are barely managing, who endure rather than flourish, who pass their link to their children with a relief that they hope does not show too clearly. Some links are tested by crisis, by the failures of systems and societies, by the dark nights of the soul that isolated existence produces, by the generations that looked at the walls and asked why and did not receive a satisfying answer. But the chain holds, not perfectly, not without cost, not without the loss of things that should not have been lost and the damage of things that should not have been damaged. But it holds, because the alternative to holding is not release, it is falling. And falling, in the dark between the stars, means everyone. We began with a number, 25 trillion miles, and we have spent this journey learning what that number actually demands of the beings who would cross it. It demands time that no single life contains. It demands sacrifice distributed across generations that cannot consent to it. It demands the maintenance of knowledge and governance and social cohesion across timescales that have broken every human institution we have ever built. It demands that we ask children to live inside our ambitions, to carry forward commitments they did not make, to pay costs they did not agree to pay. These demands are not small. They are not comfortable to look at directly. The honest accounting of what a generation ship voyage costs, in human terms, in the currency of actual lives actually lived, is one of the most sobering exercises that the imagination of our species has produced. And yet we keep coming back to it, not because we are callous about the cost, not because we underestimate what we are asking, but because the alternative remaining here, on this one world, around this one star, with all of our hopes and memories and knowledge and everything we have ever built or loved or understood, balanced on the geological and astronomical stability of a single planet in a universe that does not guarantee stability to anyone, is itself a form of risk. A slower risk, a quieter risk. Not the dramatic, immediate risk of a 1,000-year voyage through the dark, but the long, patient risk of everything being in one place, of there being no backup, of the entire story of our species depending on nothing going wrong here for as long as we want the story to continue. The generation ship is, at its deepest level, a response to that risk, an answer to the question of what we are willing to pay for the possibility that some part of what we are and what we have built might continue, even if here does not. The answer is everything. We are willing to pay everything, including generations of people who will never arrive. There is a thought experiment that I want to leave you with. Not a calculation, not a philosophical argument, not a technical analysis, a simple act of imagination. Imagine that you are standing on the observation deck of the generation ship, 500 years into the voyage. You are in the middle generation, the middle of the middle. The founding is 500 years behind you. The arrival is 500 years ahead. You have read the histories of the departure, studied the records of the people who boarded the ship with Earth still fresh in their eyes. You have studied the projected histories of the arrival, the carefully maintained documents describing what the destination might look like, what the colonists will need to do, what success might mean. And you are here, in the middle, in the long present tense that has no edge you will ever reach. You walk to the observation window, the one that faces forward, toward the destination. The star is visible but still small, a point of light slightly brighter than its neighbors, distinguishable from them only by the instruments that have tracked its gradual brightening across the centuries. You look at it for a long time, and then you turn around. You face the window that looks backward toward where you came from, toward the sun of your ancestors, the star that Earth orbits, the warmth that every human being who ever lived before the ship's departure was born under. It is invisible, not too dim to see, simply indistinguishable. One star among the hundreds of thousands visible in that direction. You cannot find it. You cannot point to it. You cannot say, "There, that one. That is where we came from. That is the light that fell on the faces of everyone who ever loved or suffered or created or discovered anything before us." It is just the dark, full of stars, no one of them yours. And you understand, standing at that window, something that cannot be fully understood any other way. You understand what it means to be between, not arriving, not departing, not the beginning and not the end, the middle, the necessary, unremarkable, unglamorous, essential middle, without which neither beginning nor end has any meaning. You are the middle. You are the link. You are the one who holds the chain taut across the void, not because you chose to, not because you were heroic enough to accept the burden, but simply because you were born here, and the chain requires holding, and you are the one who is here to hold.